Greetings, welcome to this new video about superposition theorem. Solve the problem number 5. In this video, I will demonstrate the application of the superposition method to solve a problem. And I will guide you through the step-by-step process of using superposition to solve the problem at hand. Let's consider this network consisting of 3 resistors labeled R1 through R3, as well as 2 independent voltage source VA and VB and 1 independent current source IS. The question now is to calculate the current I through the resistor R3 using the superposition principle. Let's move on to the solution. First, we begin by identifying each independent source in this network. This step provides a clear understanding of sources that will be analyzed separately. In these circuits, we can observe 3 independent sources, 2 independent voltage sources VA and VB, and 1 independent current source IS. Next, we proceed to deactivate all but 1 independent source in the network. This involves replacing the inactive voltage sources with short circuits, which means it's zero voltage, and the current sources with an open circuits, which means it's zero current. Let's begin by activating the independent voltage source VA and deactivating the independent current source IS and the independent voltage source VB, which will be replaced respectively by an open circuit and short circuit. The next step is to solve the circuit using conventional techniques. In order to calculate I1, let's first start by calculating the equivalent resistance is equal to R1 plus R2 plus R3. If we replace R1, R2 and R3 with their numerical values, we obtain R equivalent is equal to 16 ohms. And according to Ohm's law, I1 is equal to VA over R equivalent, and if we replace VA and R equivalent with their numerical values, we obtain I1 is equal to 8 over 16 amps. Now, let's consider the independent current source IS active and the independent voltage sources VA and VB inactive, which will be replaced by a short circuit. This circuit can be simplified as follows, where R13 is equal to R1 plus R3. And if we replace R1 and R3 with their numerical values, we obtain R13 is equal to 14 ohms. In order to calculate the current I2, we applied a current division method. That means I2 is equal to R2 over R2 plus R13 times IS, and if we replace the resistance and the current with their numerical values, we obtain I2 is equal to 4 over 16 amps. Now let's consider the independent voltage source VB active and the independent voltage source VA and the independent current source IS inactive, which will be replaced by respectively short circuits and an open circuits. First, let's calculate the equivalent resistance is equal to R1 plus R2 plus R3 is equal to 16 ohms. I3 is equal to negative VB over R equivalent according to Ohm's law. And if we replace VB and R equivalent with their numerical values, we obtain negative 6 over 16 amps. After completing the analysis for each independent source while treating the others as turned off, the subsequent step is to combine the results algebraically. This process enables us to determine the overall circuit's response. That means the current I through the resistor R3 is equal to I1 plus I2 plus I3. And if we replace I1, I2, and I3 with their numerical values, we obtain I is equal to 16 over 6 over 16 is equal to 375 milliamps. After we finish the calculation, we conduct a simulation using a SPICE simulator in order to verify our results. Let's proceed now to the SPICE environment. Here is our network drawn in SPICE simulator. This is the independent voltage source VA and the independent voltage source VB and the independent current source IS, resistor R1, R2, and R3. Let's move on to analysis. This say analysis, calculate nodal voltages. We can see here that the current I is equal to 375 milliamps. After completing the circuit simulation, we can clearly observe the similarity between the simulation and calculation results. This serves a validation of our work. Alright, thank you for watching this video. If you have any question, do not hesitate to contact me by email or leave a comment under this video and I will answer you as soon as possible. If you like this video, don't forget to subscribe and share. See you next time in another video about superposition theorem. Take care and bye-bye.